WD 2.1.8.x USB unlocking and firmware repair. We chose a WD Passport Ultra 2 TB mobile hard drive as a case study. Hard drive model number is WD20SDRM. PCB board number is 2060-810003-001. The disk with firmware lock cannot get the ROM directly through the program, it needs to use the physical method. We remove the screws and use tweezers to remove the PCB board from the clips. Find and confirm the ROM chip. We need to desolder it using a tool such as a hot air gun. The purpose is to read out the ROM data using the programmer. After confirming that the programmer cable is connected to the MRT hardware card, make sure the programmer cable is properly connected by looking at the notch given by the new Programmer 3.0. At the illustration, we confirm the placement of the chip and find the small dot of the chip. After placing the chip, you can use tweezers to slightly correct the position of the chip. Enter the programmer editor. Select Western Digital ROM. It shows Programmer 3.0, which is the new programmer. Click Tools, Chip Data Viewer. Here select 32 KB size to quickly confirm if the data is normal. Most of the Western Digital ROMs start with 5A04. After confirming the header is correct, we then select the corresponding ROM size according to the board number. The documentation lists some mainstream board numbers against the ROM size. The current hard drive board number is 810,003. Therefore, you need to read 1024 KB ROM size. Look for the 524F594C data to confirm if the internal data is normal. This is to check the data roughly and exclude the data interruption caused by poor pin contact. If a large amount of FF or 00 data is suddenly displayed, we create a directory and name the ROMs. It is recommended to make a backup and keep 2 ROM files. Back to the main panel, be careful not to exit the programmer program. Click to enter the WD main program. (8100003) corresponds to 800,065 charger family. Click on Firmware Unlock. Select the corresponding path. Make sure to select the original ROM file here. You can see that the generated file is prefixed with unlocked, which is easy to find later. Let's go back to the programmer program. Expand and select the unlocked ROM file. Click on Tools, turn off Chip Write Protection. We write the unlocked ROM to the chip. After writing, We select the 32 kilobyte size again to read the chip data. Quickly make sure that the read header data is the same as the written data. After power off, we need to solder back the ROM chip to the USB board. Explanation on the cause of ROM data read error. After selecting 32 kilobytes to read the ROM, we find that the data is all FF. There are two reasons for most of them. One is that the programmer cable is not properly connected to the MRT hardware card. This can be confirmed by the 3.0 version shown in the programmer interface. The other is that the ROM chip is not placed correctly, such as the chip not pointing to the center of the programmer, or the chip pins are not in proper contact with the metal contacts of the base. (480041) unlocking failure case show. We select the path 800,022 to 800,041. Pick a ROM to unlock. Found that unlocking failed. In fact, not all models of 800,041 come with firmware lock. After confirming that the ROM data, family selection, and new programmer connection are correct, it can be determined that this type of disk does not have firmware lock. At this point, you can directly use the 800022 SATA processing. Let's choose a ROM with firmware lock to unlock it. Here we delete the unlocked ROM first. The unlocking is successful, that is, the firmware lock exists. We connect the USB drive with the unlocked ROM to the PC. If you want faster copy speed in the future, we recommend connecting the drive to the USB port of the motherboard. We wait for the PC to recognize the device. 360 U Disk Assistant appears, indicating that the partition can also be accessed normally. Let's see what to do when the partition is recognized. Later we will learn how to deal with the partition when it is not recognized. We open Device Management. Confirm the status of the device and the partition. Now enter the WD USB program and first select the USB device. Since it is already unlocked, we click on Auto Detect to identify the family. Now the ID and firmware are obtained. Click on Full Resource Backup. Remove tracks and check the box Skip 190 module. Since the 190 module does not have module verification when reading in the ID way, if a bad track is encountered, it will continue to wait for a timeout anyway, and will not skip the bad track. This will result in subsequent modules not being backed up. After the backup is finished, expand the module list. Keyboard input 0183 to locate module 183. Manually backup 183 plus 190 modules to the same folder. Note, if the 190 module does not read well, you can try to get the LBA entry through the default option of T2 Editor. Now go to the Data Explorer module and create a data copy task. When making head map, we select Get from File, Module. Select the corresponding directory. Note that the duration of the head map depends on the amount of data, the status of the heads, and the status of the disks. Here we recommend some settings for reference. The read block size is related to the head and disk status. 200 and below are mainly for the case of weak heads or poor disk status. Now we demonstrate the problem of memory 190 loss in T2 editor. How to re-image the red normal and all zeros data. Clearing the sector bitmap needs to be done in the current interface. First, we have to make sure that the memory 190 data is successfully loaded in the WD program. We will continue imaging for a while and click Stop. Find the end of the imaged data. Randomly select a blank sector. Right-click and select Copy Current Sector LBA. Paste the LBA address to the end LBA. Select only sector all zero type. After confirming, find the all zero sectors are shown in white. White is not copied sectors. In the task parameters, paste the LBA address to the end LBA of the task. When imaging again, only the all zero sectors of the current LBA segment will be imaged. After that, the LBA address can be used to handle the all zero sectors of other LBA segments. The preceding shows how to handle a normally recognizable USB drive. Let's look at how the drive behaves on the PC side when it fails. In disk management, you can see the drive is in unallocated status. Right-click Properties to confirm that it is the failed drive model. We still use the same unlocking method as shown in the tutorial. Write a permanent unlock ROM via MRT and use the original USB board. First, enter the WD USB program to confirm if the drive recognizes the ID. Since the ID and firmware get normal, you can directly check sector 0. Found abnormal sector 0 data. We entered 2048 sector number. Found that there is a normal boot sector structure. This means that the data is actually still there, but the hard drive is not recognized on the PC due to abnormal sector 0 data. The next step is just to image the hard drive data normally. Due to the presence of data in sector 0, we temporarily rule out 190 failures. We confirm the common boot sector number, such as 63 20 48 40 96. Check whether there is a normal boot sector structure. The last 2 bytes are 55AA. The first boot sector of NTFS system is mostly in 2048 40 96. If the boot sector and other sector data is 00, we consider that the 190 module entry error causes the data all zero problem. Fault categories. Let's summarize the types of failures of non-firmware failure. There are 2 main causes. 1. The existence of bad sectors of the hard drive leads to incomplete identification of the hard drive ID and partition. The hard drive shows unassigned status. 2. Abnormal hard drive partition table data, such as data errors or partition table loss. The hard drive shows unallocated status. The above reasons do not involve firmware failure, such as 190 data problems resulting in full 00 problems. B. Firmware failure. In the case of excluding head damage or hard disk scratches, the main reason is the 190 module data abnormalities. The performances of the hard drives are as follows. 1. When connecting USB drive to the PC, the computer did not recognize the device. The reason is generally the hard disk does not recognize the disk or long busy. The device ID is not obtained. 2. Automatic stop after power on, or repeated automatic power off power on. The reason is the abnormal 190 entries that leads to power on failure. 3. Display unallocated status, partition is not recognized. The reason is mostly 190 entry problems resulting in data all 0, or a large amount of data loss and loss of partition table. Summary. By Diagnosis, it was found that the original USB disk shows unallocated status. There are two possibilities for its cause: firmware failure and non-firmware failure. The judgment of whether direct access to data is possible is based on normal capacity plus the presence of non-zero data in the sector. That is, when the capacity is abnormal, it is almost always a firmware problem after excluding head failure or scratching. When correct capacity is identified, the data may be all 0, or may be normal with few bad sectors or partition table loss. Now we provide an operation process. Step 1. Write the unlocked ROM to the original USB board using the tutorial method. Step 2. Confirm if the drive recognizes capacity and shows unallocated status. Step 3. When the capacity is normal, even if it is unallocated, it still gives priority to the WD-USB program to confirm the sector data. Step 4. When the capacity is abnormal, observe the power-up sound to exclude head failure and scratching problems. Step 5. The remaining issues are handled in accordance with the firmware failure. Please be sure to watch the tutorial in full to understand the operating ideas. Now we take the typical 190 fault caused by power on unrecognized as an example to demonstrate the complete operation process. Confirming the hard disk in Device Manager. When switching to disk management, this pop-up appears. We must click Cancel. At this time, the hard disk is not initialized, showing unallocated status, but the capacity is normal. Enter the WD-USB program. Auto detection shows failure. After entering the program, the ID and firmware acquisition fails. The reason is that the hard drive is in a firmware failure state at this time and the command sent is not responding. So how do we deal with it? The solution is to short into safe mode. Since the original USB board master is the key to solving the data encryption. Here we do not recommend using the USB board for shorting to avoid damage to the USB board. It is recommended to prepare a corresponding SATA board number to handle. The current board number is 810,003 as there is already an unlocked ROM. We use the 800,065 SATA board with lock as a case for demonstration. We have prepared a SATA board with board number 800065. After confirming the ROM chip, you need to download the ROM chip. If it is an unlocked board, you can write the unlocked ROM directly through the Western Digital Write ROM function. Now we place the ROM chip to the Programmer 3.0. Enter the Programmer program and select the WD type. Follow the same method. First select 32 kilobytes to confirm that normal data can be read. Select the normal size to read again. Since the ROM data has been backed up, we choose to unlock the ROM. Turn off the chip write protection and write data to the ROM chip. Next, we need to solder the chip back to the prepared 800,065 SATA board. Now both SATA and USB boards are using unlocked ROMs. We swap the boards and use the SATA board to handle the firmware. After the swap, we connect to the MRT device, which at this point does not need to be connected to the PC side. When we encounter 190 data exceptions that cause long busy, we need to wait a long time before we can operate. We manually select the family and first enter the kernel mode. After waiting for about 2 minutes, the drive long busy light went off and the drive status light blinked for a while. At this point, it means that the firmware is accessible. After getting the firmware, first back up the ROM and ROM module. Then disable 411. Disconnect and power up the hard drive. Enter normal mode. At this point, the ID is not recognized. The first step is to back up the firmware. Then skip 190 for backup. After that, manually back up the 183 plus 190 module. Skip 190 because 190 of malfunction drive usually contain lot of bad sectors and the backup time will be very long. After the backup, we expand the module list. Note that you need to save the 183 modules and 190 modules in the same folder. We keep the 190 header 2 lines, clear the rest of the data and save it as 190.00.rpm module. We write the data to the 190 module, i.e. we clear the 190 data. After the write is complete, we enable 411. Power off and on. Refresh the drive information and find that the ID can be recognized. Through the sector viewer, we found that the data is 00 at this point. We open the T2 editor. Select Get from File module. After confirming the presence of a normal green entry, we offer 2 ways to handle 190. The first method is that when there are multiple yellow empty entries and red error entries in 190, we do not rebuild but save directly as a T2 data file. Select Get from File, T2 Stream Data, to load the file and write it to memory. Now we demonstrate another method to rebuild T2 data directly and check both options to write 190 to RAM. After a successful write, we click on Soft Reset to exclude abnormal data. Refresh the sector data and find that it is encrypted data. This means that the 190 entry is normally valid. By this point, We have dealt with the disk identification problem. Need to switch back to the original USB board and connect to the PC side. We open Computer Management, Disk Management. We found that the device is not initialized. Click Cancel. The hard drive is in unallocated state and the capacity is normal. Back to MRT interface, we enter WD USB program. After identifying the ID and firmware, we expand the T2 editor. Since two options have been checked last time, we write 190 data directly to RAM this time. Check the sector data and confirm the last 2 bytes are 55 AA, which means the data is normal. Enter the Data Explorer module and we create a copy task. We create the head map and select the folder where 183 and 190 are located. Open the DE settings interface and follow the tutorial to make simple settings. After the settings are done, we browse in the file to see if the data is normal. You can preview it to confirm. Now we image the data. Again, demonstrate how to clear the sector with all 00 when we find the memory 190 data is missing. We need to determine the LBA range to clear. Here is a reference. After clearing the sector map, the sectors are white unread sectors, so you need to check the white sector type. After re-imaging, the data will be filled to the target disk. The copy speed here is affected by the USB interface. Since we connect to the front USB port of the PC, the speed is relatively slower. We can connect to the motherboard USB port on the back of the PC from the beginning, and select the USB 3.0 port. The final note: 1. The use of SATA board processing firmware is mainly to avoid damage to the original USB. 2. The original USB board can be used without considering the data encryption problem. 3. The method demonstrated in the tutorial can avoid modifying the native USB to ensure the integrity of the USB board. 4. The USB reading is relatively slower than SATA solution, however, to some degree it can prevent auto power off and on issue, which is commonly observed during the data copy process while using SATA board.